So we are having a look at equations, like I say, and our very first question here, we've got 4x minus 2 equals -3. All right, so when we're looking at equations, remember the really important thing that we want to take note of is what inverse operations are we going to use to solve this equation. Now, inverse is basically opposite. And so what that means, I can't spell operations today. And so what that means is when we solve an equation, we want to do the opposite operation to what it originally was. So what I mean by that is if we had a plus sign originally, we now want a minus. If we had a minus sign, we now want a plus. If we had a multiplication, we now want to divide. And if we had a division, we now want to multiply. Right, so that's really important to know because when we start to solve this equation, we're going to have to use these inverse or opposite operations. So looking at my equation, sometimes what I like to do is just highlight the variable I'm trying to solve for. So I can see that I'm trying to solve for this x, and essentially the goal when I'm solving an equation is to get x alone. So one of the things that we've spoken about is getting all our x terms to the left. Oopsie, so sorry, maybe I should spell. Terms to the left. I'm just going to be lazy and use L for left. And then we want to get our constants, so just the numbers to the right. Right, and this helps us basically solve our equation. If we've got a goal of where we want to put terms, then at least we sort of know where to start. So if I look at my original equation that I have here, the first thing that I see is that I've got this -2 term. Now I want to get that because that's a constant to the right-hand side. And in order to do that, I have to use these inverse operations that I spoke about. So if this was a -2 originally, the inverse of that is a +2. And I am going to add 2 in order to get that to the other side of my equation. Right, so that's essentially what I do. Now this next step, you don't have to write down as I'm going to write it down. If you want to go straight to the simplified answer, that's absolutely fine. But essentially what I'm doing on either side is I'm adding 2. By adding 2 on the left-hand side, essentially -2 plus 2 cancels out. So I'm just left with the 4x, and then I've brought it over my equal sign. So now I've got a -3 plus 2, and that simplifies to a -1. Okay. Now I'm still solving for x. I don't have x alone yet. The next thing that I see I have to deal with is this coefficient of 4. Now, if someone wants to raise a hand, you're more than welcome to, but otherwise you're welcome to pop it in the chat. Who can tell me what operation is happening between the 4 and the x in that term?
Let's go, my people. Yes, Tero. You want to say the answer, Tero, on your side?
Hello.
Hi.
How are you?
Good.
Ma'am, I don't understand how you guys got the +2.
Okay, so I'm just moving it over the equal sign. I want to put it on the right-hand side, and to do that, I have to do the opposite of what it was. So it was -2, so I have to +2.
Oh, thank you.
Right. I'm seeing some awesome answers coming through in the chat. Well done, everyone. It is multiplication. So what we know is that between the 4 and the x, we have got 4 times x. And so we know what operation we were originally working with. Okay, so that's really important. I need to know my original operation so that I can do the opposite. So if the original was times, then the opposite is going to be divide. So that means I have to divide both sides by 4. And that's going to get rid of the coefficient of 4. And so what I'm left with is x is equal to -1/4 or -1/4. And by using my inverse operations, I have solved for x. Okay, so those inverse operations is very, very important. We need to be able to use them to solve our equations. And the only way we can sort of start to move things away from x or move things over the equal sign is using inverse operations. Okay. Cool. So guys, remember any specific questions, please feel free to ask. I can't really help if you just say you don't understand. I need to know exactly where you're going wrong so that I can try and help you. Okay, so inverse operations. We're going to do another example like this now. And if you get a fraction answer, don't panic. Sometimes fractions are just what the answer is. That's okay. Okay. So let's have a look at what we have here in example 2. We've got 2x plus 4 is equal to 12. Now, this is very similar to the one we've just had a look at. We want to use inverse operations, and we want to go and solve for x. All right. There is my x. I want to get the constants to the right and keep the x's on the left. Now, my x term is already on the left-hand side. So essentially what I want to do here is I want to take this plus 4 and I want to move it over to the right-hand side. Okay. When I do that, I use my inverse operation. So I'm now going to subtract 4 because that's the only way I can move it to the other side. And so now I've got 2x is equal to 12 minus 4. All right. That is because I moved the plus 4 over the equal sign and became a minus 4. It became the inverse, the opposite of what it was. I can simplify 12 minus 4 to be 8. So I've got 2x is equal to 8. And then very similar to what we had in the last question, I know that this is a multiplication between the 2 and the x. And the opposite of multiplication is division. So I need to go and divide both sides by 2. And that then means that the 2's go away and I'm left with just my x. And so x is equal to positive 4. All right. So when we are doing these, inverse operations is super important. We need to make sure that we are using the correct inverse operation. And we need to make sure that we are sort of keeping our equation balanced. So for example, over here, when I divided by 2, I didn't just divide the 2x by 2. I also divided the right-hand side by 2 because I have to make sure my equation stays balanced. All right, so inverse operations, very, very important when we are solving equations.
Okay, so there's many questions. So guys, this example is sort of the same with the other one. Okay, so I hope you did give this one a try. Let's go to the Hleko. We are all yours. I'm only going to take 3 questions. So you guys, please do your question in the chat. Okay. Hleko, you can ask your question. Hi, Hleko, are you there?
Yes, ma'am.
Okay, how can we help?
Ma'am, I don't understand when you said 4x divided by 4 equals to negative 1 over 4.
Okay, so if we have a look again at example 1, I have to get rid of the 4 in front of the x. And the only way for me to get rid of that 4 in front of the x is to divide it by 4. Now, like I just said in the last example, if I'm going to divide the left-hand side by 4, so let me just get a color here. So if I'm going to divide this side by 4, I also need to divide the other side of my equation by 4 to keep it balanced. And negative 1 divided by 4 equals negative 1 over 4, or negative a quarter. So that's essentially where I got that answer from. Now, I saw someone also ask, do you need to ever convert it to a decimal? You can, but you don't have to. I prefer fractions, but if you write it as negative 0.25, that is fine. Okay, but like I say, fractions are preferable. Okay, so Hleko, does that make a little bit more sense where you got that negative 1 over 4?
Yeah. Okay, so now we have Palesa. I think that they go is okay. Palesa,
Hello, ma'am.
Hi.
Hi.
Ma'am, where did you get the +2 from?
In this first example?
Yes, ma'am.
Okay, cool. So I got the +2, remember, because what I wanted to do was I wanted to take this -2 and move it over the equal sign. And the only way I can do it is to then do the opposite. So to +2.
Oh, yes, ma'am. Thank you so much.
Good, well done.
Okay, so I guess this is my last question. So, Lebohile, we are all yours, even though I see on the chat you're saying you understand. So I'm not sure if that hand is up for a question. Lebohile, do you want to unmute on your side or are you okay? Hi, Lebohile. Okay, Lebohile, you can also put your question on the chat. Hey, it's also going to be fine. Rory Sang, I'm going to come to you and you're the last one that I'm going to take now.
Hi, ma'am. I wanted to ask that by the first example, how was it possible for you to make it into a fraction to get the answer?
Okay, so the reason I got a fraction is because I was dividing 1 by 4. So if I look at this step over here, if I sort of break this down, this is a -1 divided by 4. And if I write that as a fraction, it's -1 over 4. I can't divide 4 perfectly into 1 because 4 is much bigger than 1. So I end up with a fraction. Okay.
Thank you, ma'am.
Okay, cool.
Thank you.
Pleasure.
Okay, we can move on now.
Okay, cool, guys. Really nice questions. Well done. We're all listening to each other. That's really awesome. Okay, so let's have a look at something like what we have in example 3. Now, example 3 is a little bit different because of the fact that we have x's on both sides of the equal sign, but that's not the end of the world. We just follow the little rule or trick of we get all the x's to the left. So I'm just going to write it again, all x terms to, and I saw someone in the chat said LHS. LHS means left-hand side, and you're welcome to use that. And then we want to get all our constants, so just the numbers, to the right-hand side. So if we can follow this, then we should be okay. And we just have to remember our inverse operations. So if I have a look here, the first thing I want to do is I want to take the x that is currently on the right, and I want to move it to the left. The only way I can do that is to do the inverse of what it was. So this was originally, I don't have to write this plus, but it was originally a plus x. So the opposite of that is minus x. And so what happens here is I've got a 5x minus x is equal to that positive 8. I don't have to write the plus in front. I can leave it as just 8, but I've moved my x term over to the left-hand side where I want it to be. Now I can go and say, okay, well, on the left, I've got like terms because 5x and x are like terms, and I can subtract the x. So this becomes 4x is equal to 8. And now this is very similar to what we saw in example 1 and example 2. So we know how to do this. I don't want that 4 there. It was a times, so now it must become a divide by 4. But I must remember to do that on both sides to keep my equation balanced. And I'm seeing some wonderful answers coming through. The 4's cancel each other because 4 divided by 4 is just 1. And we know that 8 divided by 4 is 2. And so in this case, x is equal to 2. Well done, guys. Seen some great answers coming through. Excellent.
Well done, my people. So I have 2 questions. Remember, guys, if you do have a question, raise your hand, but also try to put your question on the chat so teacher Sam can help and I can also help. Okay, like this we move faster and effective. Hi, Tero.
Hi, ma'am. Ma'am, how did you get the, 4 divided by 4, the 4 on top?
Okay, so the 4 on top came from the step before where I said 5x minus x because those are like terms. So if I've got 5x and I take 1x away, I'm left with 4x.
Oh.
Okay, so
Thank
it's just
you,
adding
ma'am.
pleasure.
Okay. Sireletso, we are all yours.
Hi, ma'am.
Hi.
I would just like to ask, I was doing just fine with step 3 following you, but then I got lost when it came to where did we get 4x equals to 8?
Okay, so I've just explained this one. It's coming from the step before when I took the like term. So 5x minus 1x leaves me with just 4x.
Oh, okay. Now I
Okay, so
get
it's
it.
from the, sure.
Okay, so Rory-san, we are all yours. And I guess Rory-san is the last question that I'll take, right? So you guys, please put your questions on the chats. Rory-san, we're all yours. Go ahead.
So, ma'am, I wanted to ask, since it was 5x minus x, how is it possible for you to get the fraction 4x over 4? Because it was 5x minus x is equals to 8.
Okay, so the 4x comes from, like I said, taking the like terms and subtracting them. So 5x minus x is 4x. And from there, because I'm wanting to solve for x, so because I just want that x alone, I need to get rid of that 4 somehow. And the only way for me to get rid of something that's being times is to do the opposite, so to multiply. So that is why I then went and said, okay, well, now I'm going to divide by 4, because that's the opposite of multiplication, because I know 4 divided by 4 is actually 1, and 1 doesn't change anything. 1 doesn't change the value of anything that I'm working with. And so by dividing by 4, I'm just getting x alone.
Thank you, ma'am.
Okay, pleasure. Right, guys, so let's try another one like this. We've got 3x equals x plus 4. So I'm going to give you like a minute to give it a try by yourself. If you have questions, put it in the chat. And what I'll actually do is I will make this a bit smaller so you can see what we were doing in example 3. And you can see all my notes. And hopefully that'll help you get to your answer in example or in question 4. Please feel free to put your hands up if you'd like to share how you got your answer or tell us how you got your answer. You're welcome to also just put it in the chat if you're not feeling that brave, but please feel free to share with us.
Yes, I hope those hands are to answer the question already. We are all yours. Are you asking a question, my man? Divine, you have to unmute on your side. Try to press that little box that comes. Hi.
Hi, ma'am. Can I answer the answer? The
Absolutely. Absolutely. Go for it.
So I said 3x minus x equals 4.
Cool.
And then I also got my answer. Then it said 2x equals 4. Then I divided it by 2, which x equals to 2.
Awesome. Well done. That's excellent.
Thanks, Divine. That was nice.
You're welcome, ma'am.
Awesome, guys. So that is exactly it. And Divine explained it exactly how you need to do it. First thing I'm going to do is take the x, move it over. So it becomes minus x. I need to do the opposite. So that is where in the second step, I'm getting this minus x from. I then got like terms, and I'm explaining it now, guys. So if you have questions, I would listen. We then have like terms. 3x minus x gives me this 2x over here. And then remember, the goal is to solve for x. So I'm trying to get this x alone, which means that I need to divide both sides by 2 in order to get that x is equal to 2. Well done. Really, really nice.
And Sheko, is that to now ladies, you said that you want to answer the next one. So I'm on next, and you can lower your hand. I'll call on you when everyone has tried the question. Sheko, is that a hand to ask a question? Do you have a question?
Yes, ma'am, it is a question.
Cool.
Okay.
Ma'am, can you re-explain the whole thing from 2x divided over 2 equals to 4 over 2?
Okay, so you understand where I got the 2x from?
Yes, ma'am.
Okay, so remember, I don't want 2x, I want x. So what I need to do is I need to find a way to just get that x alone, which means I have to get rid of the 2. Now it was 2 times x, which means the opposite operation is to divide. So what I'm doing with this 2 here is I'm dividing by 2 because that essentially cancels that 2 away, it cancels it out. And so I'm just left with the x that I want. So I have to always divide away the coefficient to just get the variable. Does that make sense, Ntego?
Yes, ma'am.
Cool.
Okay, Teacher Sam, can we have that question in the middle? Because some students says that they cannot see there.
The question in the middle.
No, like, can we have question 4 that we just did now? Can we have it like in the big, yes, like this, they can see it.
Awesome.
I hope that helps you guys. Screenshots time. Now, lady, I'm guessing that's a question. Go. I'm not sure if I should stop saying go. I don't know whether it's a go or a boy. Hi, now, lady.
Yes, ma'am. Yes, ma'am. Ma'am, my question was, ma'am. So, yes, ma'am. Hi, ma'am. So my question was, ma'am. So, for example, let's say, 3x equals x minus 4. So when we move the x down, will it be 3x? Will it be 3x plus x?
Okay,
Or
so
will it stay?
in the example you've just given me, which I've just scribbled on the side there, because this x is still a plus x, when you bring it over, it will still be minus x. So it'll be 3x minus x equals minus 4. The only time it'll be plus x is if your equation had been 3x equals minus x plus 4. Because then when you want to bring that x over, we change the sign, so then it becomes plus x. Does that make sense?
Yeah, I think Naledi got his answer because I can see that he reads it himself.
Cool.
Yes, says yes. Okay.
Yes. So guys, just so that we are very clear, I got x equals 2 because when I divide 4 by 2, so 4 divided by 2, I get 2. That's where I got my answer from, okay? Alrighty. So let us move on over to question 5 over here. So this is quite similar to what we've been doing, nothing too new. What is a little bit new though is the fact that I've got a few more terms that I'm working with. All right, so let's try this one. Remember, we want to get x's to the left-hand side, and I'm just going to keep making this note. You're going to be dreaming of x's on the left-hand side. So x's on the left-hand side, constants on the right-hand side. Okay, that is my goal. So the first thing that I see is that I've got a 2x on the right, but I want it to come over to the left. Now that 2x has a plus sign in front of it. I don't write it there, but I know it's a plus, which means that I have to do the opposite. I now want to minus 2x. So what that's going to leave me with is 4x minus 2x plus 2 is equal to 4, because remember the 2x is gone on the left. I've moved it over. I mean, on the right-hand side, sorry. I've moved it over onto the left-hand side. Now what I want to do is I want to get the plus 2 that's sitting on the left, so this one over here, and I want to move it over to the right because that's what we want, constants on the right-hand side. So when I do that, I'm going to end up with all of my x's on the left, 4x minus 2, and all of my constants on the right. Now remember, when I take this plus 2 over, it becomes minus 2. It's really, really important we remember that inverse operation. So we've got 4 minus 2. Now I can add and subtract my like terms. 4x minus 2x is 2x, and 4 minus 2 is 2. Now, guys, remember, the whole point of solving an equation is to just get x alone. I don't want 2x, I want x. So I need to get rid of the coefficient by dividing it away. That is the only way I can get rid of the coefficient or the number in front of x. And so what I'm left with is x is equal to, and we know that 2 divided by 2 is 1. So when I take 2 divided by 2, I end up with my final answer over here. Okay, so awesome. Well done. If you said x is equal to 1, that's great. In this case, x is indeed equal to 1.
Okay, so I see some questions. We have some questions. Linda, we are all yours. Remember, the rest of you, you can listen to the answer. Maybe your question can be answered, okay?
Yes, ma'am. The question 5, is it not supposed to be 4x minus 2x equals 2 plus 4? And then you give the answer.
Okay, so just be careful. It's not going to be 2 plus 4 because remember this plus 2, when I bring it over, becomes minus 2. So it's actually 4 minus 2. The sign has to change.
Okay, ma'am.
Okay, so it's really important we remember that.
Yes, ma'am.
Okay, Vanessa, we are all yours. Please unmute.
Hi, Vanessa.
Ma'am, I used a different method.
Okay.
Ma'am, so I said 4x plus 2 minus 2x equals 4. Then I said 4x divided by 4 equals 4x divided by 4, which is x is equals to 1. Ma'am, can you
Vanessa,
get
can you say it a bit slower for me? Sorry.
So, ma'am, I said 4x plus 2 minus 2x equals 4. Then the next step is 4x divided by 4 equals 4 divided by 4.
Okay,
then
so
4 cancels 4, which we are left with x, and then 4 divided by 4 is 1.
Okay, so from this step,
yes, ma'am.
how did you get to that?
Ma'am, because when we say 2 minus 2, it gives us 0. So we cannot add the 0 there. So we're just gonna keep the.
Okay, so what we need to be really careful of is those two terms are not like terms. So you can't add or subtract them. One's got an x and the other one's a constant. So we can't actually subtract the two.
Yes, ma'am.
Okay, so
Thank you, ma'am.
Be careful. Sure. Alrighty.
Okay, so I'm gonna take the last person now, guys. We have Lisikanya. Lisikanya, we are all yours.
Hi, ma'am.
Hi.
What's this thing? You see the last step, ma'am?
That says step over here. Whoopsie. That
yeah,
one.
but the answer that says x is equal to 1.
Yeah.
Isn't it? It's supposed to be x because they say that you can't put 1. Isn't it like that? Because x is representing 1.
Say the last part of that again. X needs to be.
They say x is representing 1.
Yes.
So, ma'am, do you have to write the 1, or is it fine if you just leave it as an x?
Okay, sorry, I see what you mean. In this case, we do have to write the 1 because what I'm saying is that the number that x represents, so the number that x value has is 1. So we can't leave it out like usually if we had, I don't know, like an x term, so like x plus 2, we know there's a ghost 1 in front that we leave out. But in this case, if we're not talking about a coefficient, we're talking about an answer. So if you get an answer of 1, we do have to write 1, yes.
Oh, okay. Thank you, ma'am.
Pleasure. Sorry, guys. Okay. Right. So let us try this last one before we take a brain break. And for those of you that don't know what a brain break is, it's just a little break to give us a break from all the maths. I'm going to, again, give you some time to try it. It's very similar to what we just did in question 5. So what I'll do is I will do that so that you can see both questions. You can see how we did question 5. You can try and have a look and work with it. Remember, we want to get all the x's onto the left-hand side and then the constants onto the right-hand side. So give that one a try. I'll give you a little bit more this time. I'll give you a little bit more time this time that you have a chance to get the answer. But again, if you are feeling brave and you'd like to raise your hand and give it a try, then please do.
I already have a volunteer. So Naledi, give this a try. When you're done, let us know, okay? Because you asked me to answer the next question. So I'm gonna give this one to Naledi, but everyone else, please let's let's do this question and let's put the answers on the chat.
And remember those inverse operations, guys.
Yeah. All the hands that I see up there, I hope those hands, you're gonna get your question answered when we do this question, because it's similar to the questions that you want to ask about. Okay.
Yes, like I say, remember those inverse operations. Remember to do the opposite operation. And remember that we want all the x's on the left and all of the constants on the right-hand side. You're doing really well, guys. You're working so well tonight. Well done.
I can already see one answer they're coming on the chat. I'm going. And Naledi, I hope that you'll be ready by raising your hand so you can explain to us. Okay. Yes, Naledi is ready. Guys.
Awesome.
Let's do this.
Right, Naledi,
Okay.
if you're ready, I'm ready.
Okay, cool. So Naledi, we're taking you. Teach us. Let's hear.
Yes, ma'am. So how I got my answer, ma'am? Yes, ma'am. So how I got my answer, I said 3x minus 2x equals 7 plus 1. And then I said 1x equals 8. And then I divided both sides by 1. And then x is 8.
Awesome. Well done.
Well done.
Okay. Sorry, guys. I'm not tired. I'm not disinterested. I'm just a little bit sick at the moment. I just saw it on the chat. I promise you, I'm here. I'm with you. I'm just a little bit sick.
We'll cover you. We'll cover you, Teacher Sam. Don't worry.
Okay.
We'll cover you.
Right. So, guys, that was awesome, Naledi. Thank you.
Well done, Naledi.
When we want to go and answer this question, what we want to do is, again, use those inverse operations. So I'm explaining this question. If you didn't understand it, you need to listen. So those of you with hands up, have a listen, and maybe I'm going to answer your question, okay? So the first thing that we want to do is we want to take this 2x and we want to move it over to the left-hand side. The only time or the only way I can do that is to do the opposite. So I want to minus 2x. That's why Naledi said minus 2x over there. Now, he sort of did it all in one jump, which is absolutely fine. We also saw that this minus 1 needs to move over to the right-hand side. And the only way for that to happen is to plus 1 on both sides. That's where we got that plus 1 there. And then what you're left with on either side of your equation are like terms. So 3x minus x gave me the 1x, and 7 plus 1 gave me the 8. Now, in this instance, if you got 1x equals 8, you are more than welcome to divide both sides by 1, as you said, but dividing something by 1 doesn't actually change anything. So you still end up with x equals 8. So you can show the division by 1, but you don't have to. All right, but at the end of the day, x is equal to 8 over here. Okay, hope you can now see this question a bit better and what we were doing. And I hope those of you with your hands up, hopefully I maybe answered a question there.
Yes, Amahle said yes, she can confirm to that. Relebogile, do you still have a question that you want to ask Teacher Sam? Let's hear from you.
Hi, ma'am.
Hi.
I wanted to ask, like, I don't understand the second step. Like 3x minus 2x equals 7 plus 1.
Okay, so remember what I'm doing there is what I want. Let me start my sentence again. What I'm doing there is I'm getting all of the x's onto the left-hand side. So you can see here that I've got all the x's on the left. And what I am also doing is getting all the constants to the right. So what I've done is I've taken the 2x from the original equation and I moved it over to the left. And then I took the the negative 1, and I moved it over to the right. So I was using my inverse operations to put the terms on the correct side of the equation so that I could go and solve it. Okay.
Okay, so Lebogile said that she understood. So what we're gonna do, guys, is that Teacher Sam is gonna move on. right? That's what we're gonna do. And I hope everyone is clear on this question. Please take screenshots.
Okay, so guys, yeah, let's leave that up for 30 seconds. You can take a screenshot. I am going to move on to a brain break. So if you still have questions that you're not sure of, type it in the chat. And while everyone's doing the brain break, I'll try and help you there as we just take a little break, okay? Okay,
brain, guys, we should come up with a name to call our brain break. I know the grade 9s are calling it Brian, the brain break. You guys should be, let's be creative and find a name.
Brian, the brain break.
Yes.
My brain break's gone.
Yes.
I'm so upset about this. Let me find it again.
BRB break. Yes, the lady, BB. Okay, this class we're gonna call our brain break BB. Brain freeze. I like that one.
Okay, sorry guys. I don't know where my brain break's gone. Don't you stress.
We can stretch, it's fine.
Yeah, let's have a stretch.
Everyone, let's stretch. MTS, it cannot be headache, okay? That one, we don't want it.
I'm sorry that my camera was going crazy. That was me just trying to figure out what was going on with my brain break.
Oh, everyone, I hope you are stretching. Oh, it's just stretch. It's good for blood flow.
Yeah.
Okay, so you can get on it.
Someone's got a brain teaser. You are welcome to share it on the group and let us know. I'm terrible at brain break. It's brain teasers. It's not my strong suit. I will tell you that much.
I think this is all the brain names that they give break. Maths with
okay. See, my brain's not working. Brain relocate, reallocate.
You guys are funny. Making me laugh.
The brain train. Yes, I think we all need to get on board the brain train.
Oh, you guys. Okay.
Oh, now I'm going to have to remember all of these so I can rename it.
Yeah.
Okay, guys. Sorry, I apologize for that, but I hope you all had a stress. Who knows what happened to my brain break? It was there, but it's all right.
Yeah, we had a nice stretch, guys. Oh, I'm sitting just stretching my arms.
Okay, so let's have a look at this sort of example when we now have fractions that we need to deal with. Now, nothing changes in what we want to do. We still want to get all of the x's on the left and then all of the constants to the right-hand side. So that's not going to change. So what I want to do is, looking at this, I can see that my x is currently sitting in the numerator of my fraction. And I can see that obviously because I'm working with a fraction, there's some important inverse operations that I need to do. Now, the first thing that I'm actually going to deal with here is this +6. I know that it's a constant. I know that I want to move it to the right-hand side. And to do that, I have to use the inverse. So when I go and use the inverse operation here, whoopsie, I end up with 3x divided by 2 is equal to 12 minus 6. Now, if you're happy to immediately write the answer of 12 minus 6, that's absolutely fine. But I can simplify this to 3x divided by 2 is equal to 6. Right now, what I've got is I've got a fraction on the left and my constant on the right. Now that is okay. We don't really like fractions. And so what I want to try and deal with now is the fraction. Now, remember, a fraction represents division. Okay. So if we are originally dividing by 2, the opposite operation is to times by 2. I want to do the opposite. But if I times one side by 2, I also need to times the other side by 2. Now, multiplying by 2 essentially gets rid of that denominator. And so what it does is it gets rid of the fraction, which is great because I don't really want to have to deal with a fraction. So now I'm just left with the 3x. And then on the right-hand side, I've got that 6 times 2, which is 12. So now I've got 3x is equal to 12. Now this looks quite similar to what we had in the first few questions, because now I know that I have to divide both sides by 3 in order to get rid of that number in front of the x. That looks like a tick when it shouldn't. And so I've got x is equal to 4. So what's really important when we have some fractions is the way for me to get rid of the denominator is to multiply away, because the denominator represents division. And so the opposite operation is then multiplication. So that is how I get rid of the denominator. Alrighty. So I will leave that up there so that you can get it down. Just absorb all of that information that I gave you there. And then we'll try another one like this.
Take a screenshot, see where you went wrong, see if you can identify your mistake. If not, raise your hand and we are here to help you. And some of you, please put it on the chat, okay? Okay, so Linda, we are all yours. You can ask your question.
If you don't mind explaining again, because I didn't understand how you got 2 times 2.
Okay, so when you're saying the 2 times 2, are you talking about this step over here?
Yes, ma'am.
Okay, so once I subtracted 6 on both sides, what I saw was that I was left with the fraction. And so if I look at my fraction, it is essentially saying to me 3x divided by 2. Now I want to get rid of that division by 2. And the only way for me to do that is to do the opposite, so to multiply. So in order to get rid of the fraction, essentially, I'm just going to take this off so that I can do it a bit neater. To get rid of this fraction, I saw, okay, well, if I'm dividing by 2 originally, to get rid of this 2, I'm going to times by 2, and that gets rid of the denominator. But I need to remember to do it on the other side as well, so that I'm keeping my equation balanced. So
Okay.
does that help? Okay. Guys, you don't have to start with moving the 6 over. You're welcome to start by multiplying everything by 2 here in the original question. That's absolutely fine, as long as you remember to do it to every term. So you are welcome to deal with the fraction first if you'd like to. The reason I don't is because often we forget to multiply everything by the 2. So that's why I don't, but if you do it like that, that's absolutely fine. Okay, if you're feeling lost, don't worry, we are going to do another example.
And you guys are doing really well. And remember that if you just joined 2 classes, we are already finishing on this topic. So please do watch the previous videos, okay? Okay, Rory-san, we are, oh yeah, okay, we are moving on. Guys, try this question, and if you get stuck, Giuseppe is here to help us.
Okay, guys, I'm going to give you some time to try this. So again, what I'll do is I will make it a bit smaller so you can see what we did in the first one, and hopefully that'll help you for the second one. All right, take your time. Remember those inverse operations. Remember that when you have a fraction, the only way for you to get rid of the fraction is then to multiply away the denominator, because it was division. And then remember all of the other things that we spoke about in our last examples. Right, and if you are feeling brave and you'd like to tell us how you got to the answer, you're welcome to either put it in the chat that you'd like to answer, or you're welcome to raise your hand so we can all hear. But let's give everyone a chance to just get through the question. And guys, with your hands up, don't forget, maybe just pop it in the chat so we can get you there as well, because we don't want to miss your question. So you're welcome to pop it in the chat, or you can direct message Linda or myself.
Yes, please.
Right, the sum is question 2. It's 3x divided by 2 minus 4 is equal to 2. Okay, I'm seeing some answers come through. If any of you would like to raise your hand. Amahle, I saw, can I do it?
Can Amahle go ahead? Or you still giving them time to do the question?
No, let's hear it.
Okay, Amahle, we are all yours.
Amahle, sorry, can you just hold your microphone a little bit closer to you? There's something fuzzy going on. There we go.
Okay, I've muted you, Amati. I'm gonna ask to unmute again. Let's try that. On your side. Okay, sorry, Amati. There's just something disturbing that we cannot hear.
It's a weird static noise going on.
Yeah. So Amati, sorry, you can put your answer on the chat. Palesa, are you here to, or Rorisang? Anyone who's here to answer? Nomsa, I'm on you. Would you like to answer the question?
Yes, ma'am.
Awesome.
Okay. Ma'am, so what I done was, the sum is 3x divided by 2 is equal to, so I converted the 2 to the right, which is 2 plus 4.
Okay, cool.
Then I got the answer of 3x over 2 is equal to 2 times 2 because I took the denominator and I times it both sides.
Okay, cool. Now, have you added the 2 and the 4 together?
Yes.
Okay, so you've got 6 and then you times that by 2.
Yes.
Okay, perfect. Keep going.
Then the 2 cancels like the denominator. So then 3x is equal to 8 is equal to 6. Then I divided both sides by 3.
Okay, cool. So I'm in complete agreement with you. Just be careful that from adding 2 plus 4, you do get 6. And so when you times that by 2, you're actually saying 6 times 2. So 3x is equal to 12.
Okay.
And then we definitely divide both sides by 3, as you said.
3.
Awesome. So what is 12 divided by 3? Can you tell me?
12 divided by 3 is 4.
Awesome. Well done. Right, exactly. So x is equal to 4. Now I'm going to go through it again. So if you have a hand up or if you're feeling confused, you need to listen up. So we've got 3x divided by 2 minus 4 is equal to 2. So the first thing that I want to go and do, so I'm just going to use another color here so you can see as I'm adding. The first thing I want to do is I want to take this minus 4 and move it over. That means it becomes the opposite. So it becomes plus 4. So that's where I got this plus 4 over there. Now, when we do that plus 4, just remember that 2 plus 4 we can find an answer to. So when I say 2 plus 4, I got that 6. Now I've got the fraction that I want to deal with. Now for me to get rid of the fraction, I have to times both sides by 2, which is what I did in the red here. I times both sides by 2. So the denominator cancels away, as we said. And then we've got 6 times 2 on the right-hand side, which gives me 12. Once we've done that, we now want to just get x alone. And in order for me to just get x, I need to get rid of that times 3. So I divide both sides by 3, and that gives me my final answer of x is equal to 4. Okay. Right, I hope that makes sense. Take a screenshot so that you can do any corrections that you have, or you can come back and look at this. Remember, videos are recorded, so you can come back and watch.
Hey, my people, we are doing this. Move on.
Okay. Right, guys. Ooh. Let's have a look at question 3. So we do only have about 5 minutes left. So we're going to do this question, and then hopefully we will be feeling a bit more confident. We are going to do a few more of these in the next lesson. So if you are feeling a little bit confused, you're welcome to come back and have a look. But here we've got 3 times the bracket x plus 2 equals 9. Now, guys, remember, when we have got brackets, we need to try and deal with those first, because what this bracket is actually telling me is to multiply. So before I do anything, what I first want to do is I want to distribute. So I want to multiply the 3 into the bracket. So what I need to do here is, if I want, is I need to consider the multiplication that I need to do. So I'm going to have a little multiplication block here. I've got 3 times x, which gives me 3x. And I've got 3 times 2, which gives me 6. That is just from multiplying the coefficient or multiplying the 3 into the bracket. So if I write down those products, I get 3x plus 6 is equal to 9. Now this looks a little bit more like what we're used to, right? We've got an x on one side, we've got constants, and we now need to go and get everything to the right side of the equation, right? So first thing that I want to do is I want to take this plus 6 and I want to move it to the right because I know that's where I want to put my constants. Now to do that, I have to subtract 6. That's the only way for me to move something over the equal sign. So what I have is 3x is equal to 9 minus 6. That I can then simplify to give me 3x is equal to 3 because 9 minus 6 is 3. And then again, this is something very similar to what we are used to. I know I just want x alone, so I'm going to divide both sides by 3. And remember, as I discussed in one of our previous examples, is even though your answer is 1, you still want to write the 1 there because that is the actual value for x. So I'm saying that x is equal to 1. So yes, those 3 little dots that I'm writing in front of each step means therefore. If you don't write it, it's not the end of the world. It's just saying that I've done this step, and so now the next logical step is to go to my next one. So it just means therefore.